Today we will be talking about trigonometry. After today, you're going to be able to use sine, cosine, and tangent to find missing sides or angles of a right triangle. Here's your important vocabulary for today: opposite side, adjacent side, hypotenuse, SOHCAHTOA, sine, abbreviated SIN, cosine, abbreviated COS, and tangent, abbreviated TAN. Now, when it comes to naming angles, we've already used uppercase letters for points and lowercase letters for lines and segments. So to keep things from being confusing, we're going to use Greek letters to name angles. Your most common ones used are alpha, with the symbol shown, beta, with the symbol shown, gamma, which is like a weird looking Y, and sigma, which is the symbol shown. When it comes to naming your sides of your triangles when using trigonometry, please know that the opposite side is across from the angle we're referencing. It does not touch the angle we're referencing in any way. The adjacent side touches or makes up the angle we're referencing, but is not your hypotenuse. And your hypotenuse's definition does not change. It is still the angle across from the 90-degree or the right angle. Not the angle, the side across from the right angle. So let's practice doing some labeling of our sides. Okay. So I have these four triangles. The first thing I always do is I always circle the angle we're referencing. That helps me to see where I'm looking from. So if I were to mark the opposite, I would go across from that angle, and this would be my opposite side, which I will abbreviate OPP. Okay? Then, looking at this, the other side touching it is the adjacent side. And of course, the one opposite the 90-degree angle is always your hypotenuse. Okay. Now let's look at it from this angle. Different perspective. Again, across from the 90 is always your hypotenuse, which I will label with just an H, capital H. Let me fix that. That doesn't look right. Let's fix that and make that a capital H. Okay? Then, from the angle I have been given, the one I circled, if I go across, that's my opposite side, which I will label with a capital O. And the side left, of course, would be the adjacent. Let's try a different looking one. My reference angle here is alpha. Across from the 90 is always H, hypotenuse. Across from the angle given, or angle we're referencing from, is always opposite. And the one left over is always adjacent. Again, here's our last triangle. Circle the reference angle they've given you. This time it's the Greek letter beta. Go across from the 90, label that hypotenuse, H. Across from the angle given is always opposite, and right by the angle given is always adjacent. Okay, now that we've had some practice with this, let's get into the actual trigonometry part. You must know how to label opposite and adjacent and hypotenuse before you can start doing the trigonometry, which is what we're about to talk about. And we're going to talk about all three of the different types of trig functions we're going to be learning about in this class today. So let's start with the first trig function, sine. Your sine, abbreviated SIN, is the ratio between the opposite side and the hypotenuse. A lot of times you'll see it written as SOH, sine opposite hypotenuse. That's what the letters here mean, sine opposite hypotenuse, or sine O over H. Okay? It's the ratio of opposite over hypotenuse. Now, your second trig term you're going to be looking at is cosine. Cosine you're going to see written many ways, but it's simply the ratio between the adjacent side and the hypotenuse. Of the right triangle. A lot of people write it as CAH, cosine, adjacent hypotenuse, or cosine is adjacent over hypotenuse. The final one is tangent, abbreviated TAN. Here's a typo right here. This should say tangent. Is the ratio between the opposite side and the adjacent side. Of a right triangle. It's abbreviated TOA, tan, opposite, adjacent, but we like to say it as tan of opposite over adjacent. Okay. We do use a mnemonic when talking about these three trig functions, and the mnemonic is SOH, CAH, TOA, pronounced SOHCAHTOA, to help us remember the ratios and the setups. Some people don't prefer to write it out all in one line. They prefer to write SO, then CA below it, and then TOA below it. You'll see where this is going to come in handy here in just a little bit when we start actually working some problems. Okay, so now we're going to start trying to solve for a side of a triangle using trig. Of course, you should always check and see if you can use Pythagorean theorem to solve for the side they want you to. But most of the time, especially when we're in trig, they're not going to do that. As you can see. In example 1, they gave us side 10, but they did not give us any other side, so I can't use Pythagorean theorem. So I must use the angle they gave me other than the 90-degree angle. So I circle that angle, so I know that's my reference point. Then I immediately come over here and I write out my SOHCAHTOA, because I'm going to use that to help me figure out which trig function I'm going to use. So now I start classifying the sides they gave me and the side that they want. So I look at the side they gave me. It appears to be right next to my angle, but if I look, it's across from my 90-degree angle, so that is my hypotenuse. So I come over here to my acronym, and if one of them, and I look, and if they don't have an H in it, I cross it out, because I can't use it if it doesn't have the hypotenuse. Then I classify the side they want me to find. It is across from the angle I'm referenced, so that is my opposite side. I go back to my SOHCAHTOA here. If it does not have O, then I can't use it, so I cross it out, and then I'm left with SO. SO is sine equals opposite over hypotenuse. So now I can set up my equation. I start with sine, so S-I-N, of the angle given, 25, and I set it equal to the opposite side, x, over the hypotenuse, 10. Now to solve for x, I'd multiply the 10 over, so x would end up being 10 sine 25. And this is where having your calculator in degrees is very important. So please make sure that calculator is in degrees. If you need to, go into your settings or into your mode of your calculator and change from radians to degrees before you enter this into the calculator. Once it's entered into the calculator, you should get an answer of your side length is 4.226. So that's example 1. Now I know these take time, so we have other examples. So let's look at example 2 here. Example 2 gives me my anchor point of 50 degrees. I'm going to write out SOHCAHTOA because I need that to figure out which trig function I'm going to use. I look across from my 90 is the side they want, so that's my hypotenuse. So if there's not an H, I cross it out. I look, the 60 is across from my reference angle of 50 degrees, so that's my opposite. So I cross out CUH because there's no O. So again, I'm using sine. So I set up my equation. Sine of 50 degrees is equal to the opposite side, 60, divided by my hypotenuse of x. Now in this situation, I need to multiply the x over, then divide by the sine 50, so that x would be 60 divided by sine of 50 degrees. When I put that in my calculator, which is again is set in degrees, I'm going to get that my missing side is 78.324. Let's do a few more examples just to make sure this is making sense. So let's look at this triangle, example 3 here. My anchor point is 35 degrees. So I look, and across from that angle is my opposite. So 350 is my opposite. So when I do my SOHCAHTOA, if there's no O, it's got to go. Okay, so no CUH, can't do CUH. Then I look, X is not across from the 90, it's right next to my anchor point, so that's adjacent. So no A goes away. I scratch it out. So now I know I have to use TOA, which is tan of my anchor angle, 35 degrees, and that's equal to my opposite side of 350 divided by my adjacent side of x. Again, the tan 35 and the x will switch places. So 350 divided by tan of 35 degrees. Now, with your calculator set in degree mode, which it should already be, you would come up with that side x is 499.852. All right, on to example 4. Okay. Here's example 4. Here's my anchor angle. I look, the 100 is across from the 90, so that's my hypotenuse. So on my SOHCAHTOA here, if I don't have an H, I cross it out. So TOA's out. Okay? Then my X, the side they want, it's not across from my 44, it's right beside it, so it's my adjacent. So is out because there's no A. So I'm going to be using CUH, which is cosine, and that's of 44 degrees, and that equals to adjacent x over hypotenuse 100. In this instance, 100 multiplies over, so x would be 100 cosine of 44 degrees. When putting that in the calculator, I would get that side x is 71.934. Right. One more example of sides. Then we're going to talk about how to solve angles after this. So here's example 5. My anchor point, my anchor angle is 80. So across from the 90 is 23, which is my hypotenuse. So on my SOHCAHTOA here, if it doesn't have an H, I cross it out because I need to have an H. Then I look, the side that's unknown is adjacent to that 80 degrees. So if it doesn't have an A, I mark it out. So again, I know I'm using cosine. So cosine of 80 degrees equals adjacent x over hypotenuse 23. So x would be 23 cosine of 80 degrees. When put in the calculator, that comes out to be 3.994. Okay, so you have learned how to find these sides using trigonometry. But another thing you can do using trig is find the angles, and that's our next section. Finding the angle is a little different than finding the side. You still classify your given sides as opposite, adjacent, or hypotenuse in reference to the angle you want to find. And then to decide which trig function to use is still the same. You have to look at what they've given you and find which one contains what you have. But the trick is when you set up the function, it's the angle equals trig to the -1, which means the inverse or the arc trig function of like opposite over hypotenuse, adjacent over hypotenuse, or tangent, or opposite over adjacent. So let's do a couple examples and it will make more sense. So if you're finding an angle, you're using inverse trig, you're not using regular trig. So let's take a look at example 6. The first thing I do, circle the angle they want me to find. It's alpha. So I can go ahead and start writing my equation. Alpha equals, okay? I'm also going to write out SOHCAHTOA. All right? So I look, if I go straight across from alpha, I see 5, that's opposite. So if it doesn't have an O, it gets crossed out. Then I look, nothing is across from the 90, so hypotenuse is not being used, but adjacent is, so is out. I'm going to be using the inverse of tangent, so tan to the -1 of opposite, 5, divided by adjacent, 10. So in your calculator, you need to find out how to get the inverse tan on the calculator. Sometimes it's just control tan. Other times, like if you're using the calculators, the TI Inspire CX, you hit the trig button and it's right underneath regular tan. And when you put that in your calculator, which still needs to be set to degree, you're going to come out to that angle is 26.6 degrees. Let's keep going. Let's do another example. Okay. So here's example 7. First thing we do, write out SOHCAHTOA. Okay. Circle the angle, reference angle. Well, it's beta this time, so I know I'm doing inverse trig again. All right. So I look. They gave me across from the 90, so they gave me hypotenuse. So if it doesn't have a H, I cross it out over here. They gave me the side that is next to the reference angle, so that's adjacent. So if it doesn't have an A, I cross it out. So I'm using inverse cosine. So I write cosine to the -1, and then I do adjacent, 45, over hypotenuse of 100. And I put that in the calculator, and it gives me that angle right there is 63.3 degrees when I round to the nearest tenth. All right, just a few more examples of how to find an angle, and then you will be done with the notes. Here we go again. My reference angle is right here. So, Toa. Across from my reference angle is opposite. So if there's no O, I cross it out. And this one's right next to my angle, but it's not the hypotenuse, so it's my adjacent. No A, I cross it out, so I'm using tan. My reference angle here is gamma, so it's inverse tan. And tangent is opposite over hypotenuse, so 1,000 divided by 700. So gamma, when put in the calculator, would end up being 55 degrees. All right, let's move on to number 9, example 9. Okay, example 9, my reference angle is gamma, I believe. So I know I'm going to have gamma equals, because that's the angle. I'm finding another angle. Let me put down my acronym here. I do have a number across from gamma, so that's opposite. So Ka is out because there's no O. And then I have one across from the 90, so that's hypotenuse. So Toa is out because there's no H there. So this time I'm using sine. So it's inverse sine of opposite, 61, divided by hypotenuse, 80. And that will give me an angle measure of 37.3 degrees. Okay, let's do one more just to make sure you've got it down. Let's look at example 10. Okay, first and foremost, write out Toa. Then circle your reference angle, which is alpha this time. I know I'm using inverse trig because I'm finding an angle. So I look across from the 90 is my hypotenuse. So using hypotenuse, I don't use Toa because it doesn't have hypotenuse in it. And then I look, and across from my alpha is 10, so that's opposite. So I can't use Ka because it doesn't have an O. So I'm going to use So, which is sine. So I'm using inverse sine. And I do opposite, 10, over adjacent, hypotenuse, 20. And when I put that in the calculator, I get that this angle is 30 degrees. Okay, that's it. That's the notes for trigonometry. Now, take what you've learned and work some example for some of the problems from your assignment. And work your problems in your assignments.